Hello there, Sandy Ewins from FormaServe once again, and I'm back with a unique video today. I'll be sharing my user group presentation on temporal tables on DB2 for I that I delivered to the UK I user group in 2023. I hope you find it informative and engaging. To stay up to date on future videos in this series, kindly subscribe to our channel and don't forget to hit the like button as well. Your support is highly appreciated. Let me get on with this presentation. Temporal tables. It's about time. Says it all really. They were introduced in DB2 for I in 2016 as part of the OS release of 7.3. I gave the first workshop on Temporal as part of the IUG summer event in 2016. They are also known in other databases. Microsoft SQL Server, Oracle, and all the rest. They are not widely used or known about. Temporal tables. They are not temporary tables, it's not a typo. They allow you to query historical data by capturing the lifespan of a record based on dates. The database manager manages all this for you. You don't have to do anything for it. So use temporal tables, save yourself some time, and use these valuable assets. Temporal tables can answer many questions. Do we have a complete audit of all data changes? Auditors love these. Can you report on the price of a stock at a certain time? What was that state of that account at year end? So on and so forth. One of our clients does use them, one of the few, and they use them to track exchange rates. Very handy. So before we had temporal, how did we do this? Can be done. A lot of work, a lot of effort. Our database table in the middle there would have triggers that fires off events to the archive tables. Then trying to retrieve it, again, very difficult. Complex SQL with joins was the only way we could get the data back. Temporal has solved all these problems. So, what are temporal tables? Temporal data refers to records that are versioned. Versioning and temporal go together. For a given record is a current version and maybe older versions. We have live rows and dead rows. Rows that are not actually current. This is all managed by the database. We don't have to worry about it. It's not by journaling. And it's also known as system period temporal tables. Not very often, to be honest. Temporal tables just looks like any other normal table, a physical file, no difference. We have the same column types, normal indexes, foreign keys, constraints, etc. And database updates, reads, deletes, all done exactly the same as we did before. But temporals are really two tables. We have one for the current values and the other one for the versioned ones, the old versions. So as far as our user's concerned, he just has his normal programs, he updates the table, no difference to him whatsoever. But behind the scenes, the database manager will automatically populate our history file when it needs to. So for an existing table, what do we get? Good old user, he inserts a customer, does all his changes throughout the day, and at the end of the day, he deletes that customer. What have we got in our physical file, our table? No records whatsoever, no audit trail, absolutely nothing. So what happens with temporal support? As far as the user is concerned, absolutely nothing. He's sitting there, he's running his programs, they're exactly the same. He updates the temporal table, and then, if and then, records have to go into the history table, the database manager will decide. So in that previous example, all the records that were updated and then deleted are captured in the history table. Talking about temporal, how often do I hear, I can already do that with journaling? No, you cannot. Journaling and temporal, two totally different methods. Journaling doesn't produce relational data that you can run an SQL statement off. You can't run an SQL over a journal. The main purpose of journaling is transaction logging and recovery, often used for replication. Journaling is the wrong tool for the job. Use Temporal. As you might have guessed, Temporal works on timestamps. We have 3 extra timestamp columns that indicate the lifespan of a row. We have a row begin, we have a row end, and we have a transaction start ID. These are all generated automatically. They are created using the generated always as clause. They must be defined as timestamps with a length of 12, and they're all populated by the system clock. Our RPG program doesn't need to know about them. It certainly doesn't update them. Another attribute that temporal tables have is the system time period. The system time period column indicates the time span when the version of a row was current. It's defined by a row begin and a row end column, all maintained by the database manager. Again, RPG doesn't need to know about it. You'll see an example of this in a moment. So, how do we create temporal tables? We need 3 stages. Those stages are: we create a new table with these additional timestamp columns. We create a history table. We link the 2 together. A couple of rules we have to abide by. The temporal and its history file must exist in the same schema, the library, and both files must be journaled. Here we can see the sequel for creating a new temporal table. We add the 3 additional timestamp columns and we add a period system time register. So the first part is exactly the same. Create table, contact info in this example. First 4 fields, all standard fields. Then we have a system start column. We have a system end column. We have the timestamp ID. And then we have the period system time, where the start column is the system start and the end column is system end. So these are all generated always as row begin, generated always as row end, and generated always as transaction start ID. You can call the columns exactly what you want. I normally keep them the same because I'm normally copying it from another table, but they can be all the same. And no, you cannot do this with DDS. So before we go any further, let me talk about the history table. Temporal tables are linked to a history table. They have to be. The history table saves the old dead rows. That's a great saying. When a row is updated or deleted, the database manager, DB2, inserts a copy of the old row into the history table and timestamps it for us. It gives us the ability to retrieve data from previous times. Columns in the history table have to be exactly the same as the temporal table, no deviation whatsoever. But the history table has a one-to-one relationship with a temporal table. It cannot be linked to more than one temporal. The history table you don't have to worry about. You don't reference that with your SQL statements. Moving on to our history table. We create the history table with all the attributes of the temporal table. This is made easy by using the SQL like function. We can see an example here. Create table, the history file, and it's like contact info. So a quick statement like that is going to create the history table with all the attributes of the temporal table. Nice and easy. Nearly there. Step 3. Now we have to link the temporal and the history table together. This is achieved by using the alter table functioning and add versioning. So we can see a SQL statement down there, alter table, nothing special about that. Contact info, which is our temporal table. We add versioning and we tell it what history file to use. So use history table, hist_contact info. And that is it. We have temporal tables now, and they will work with the database manager, taking care of all the timestamps. Using ACS makes life easier with Temporal. Go into the ACS schemas and we can see the first two on here, contact info and employee, are both system period tables. They are temporal tables. And the two underneath, the HIST contact info and the HIST employee, are both history files. Naming conventions for history files, it's entirely up to you. I always put HIST at the front of them, other people put HIST at the end. Entirely up to you. I like having HIST at the beginning to prefix them with, and I can get them all grouped together. But again, your choice. So that's how we prepare new temporal tables with a history file. So how do we change existing tables? 3 steps once again really. The existing table, we have to add our timestamp columns, the 3 timestamp columns, and we also have to define the period system time to track when a row is current and when it is dead. This does not show any past history. That will not happen. And beware of level checks. If you change a table to put these extra 3 columns in, it will change the record format ID and you would have to compile all your RPG programs once again. The next step we have to take is create our history table. And this is exactly the same as it would have been for creating a new temporal table. We use the like clause to create the history table with all the same attributes as for the temporal table. So the SQL statement for that, create table, the name of the history table you're going to create, like, and the name of the temporal table. Now we have changed our existing table into a temporal table. We've created the history file. Now we need to link the two together. As before, the temporal to the history is done by running an alter table syntax. For that is alter table, employee, and we add versioning and use a history table. So that is the SQL statement for that, alter table, employee, add versioning, and use your history table. And there you go. Our existing table is now a temporal table. Inserting data into a temporal is no different than it is to a regular table or physical file. The database manager automatically generates the columns from the row end and the row begin, and it also generates the transaction start ID that uniquely identifies the transaction that is inserting into the row. Here we can see a quick disk PFM, and we see the 3 columns that the database manager has actually inserted into these columns. The start timestamp, the end timestamp, and the timestamp ID. So the first one, timestamp of when the record became current, timestamp of when it dies at the end of it, and the transaction ID, which is always the time of the first data change. And moving on to updating data. In addition to updating the temporal table, the update statement causes the database manager to insert a row into the history table. That's all part of the same transaction. We can see an update there. It's exactly the same as what it would have been previously. And moving on to deleting data. Deleting a row in the temporal takes that row and places it into the history table. Here we can see a display journal entry where this actually happens. So the first one, number 1, on the history file is doing a delete record, the DL type there, and it's actually inserting it into the history table. So PT there, done as step number 2. So now we've sorted out all our temporal tables, they're collecting data. How do we query those temporal databases? So querying a temporal table, results can include the current version and any historical versions. To query a temporal table, we specify the time using the system time keyword. If you do not specify timestamp periods on the query, the database would act as a normal SQL statement. We can run queries using the system time. To query past and present states, there's 3 ways that we can actually do this. As of, date and time, from date and time to date and time, and between date and time and date and time, You're probably saying that the last two very similar. Yes, they are. We'll go over them in a moment. Here we can see using the as of keyword. We always specified for system time, as of, and it's a snapshot in time. So the query will be select everything from employee for system time, as of, and a timestamp value. So here we can see one record returned because I'm using an EMID of 606. So it's just giving me a snapshot of that time on the 30th of April 2016. The next one using from and to. So we always have to specify system underscore time and then from and to. The from column and the end column are both exclusive, so they're not included in the query, those timestamp values. So we can see here a select everything from employee for system time, from a timestamp and to a timestamp. So they're not included, those two dates and times we've specified. They're in between. And here we can see the last one for using system time. That's using the between keyword. The beginning column of the period is inclusive, while the end column is exclusive. So it's only included in the beginning column, not the one at the end. And you can see here the query, select everything from employee for system time, between and two timestamp values. So we've got two values there for Chloe Ewens. A question I always get asked when running our training courses on DB2, do I have any temporal tables on my box? A quick simple query will tell you the answer. Everything DB2 related is in the schema, a library, QSys2. So we run a select over that, select everything from QSys2.systables, where temporal underscore type not equals n is temporal. So that will list them all out for us. Right, so now we've got temporal up and running. We've changed a couple of tables, so they're versioning it, and we got some new ones. Fantastic. But the question we always get asked, once again, how do we stop versioning? History tables do get very large, so sometimes you might need to stop them. And we use an alter table to achieve this. Alter table, employee, the name of your temporal file, and drop versioning. That will do it straight away. By running the drop versioning, you will get two lots of tables. You'll get an existing temporal table that's no longer temporal, and the history files. The history files won't be capturing any more data, but you can run queries over them if you need to. So, what's the problem with temporal? Temporal doesn't create a problem with performance. We've never seen a problem there at all. Performance is generally very good. The problem we get with temporal is the size of the history file. It does grow very large, very quickly. And one way to get around this is this thing called partitioning. Partitioning, how you say? Partitioning is very similar to multi-member files. I'm not talking about partitioning your Power 10 into different partitions. Something totally different. So partitioning will split it into chunks, and we can see down below the SQL statement for that. Creating a table, history account, it's just like the accounts, but it's then partitioned by range over a column called row end, and we can see the different partitions there. So we can see 4 partitions, 2016, 17 and 18. To do this, you do need this DB2 multi-system, part of the operating system, option 27, that needs to be installed. You do have to order that. At the moment, that is free of charge. It's part of your SWAMA, your software maintenance does include it these days, but you have to order it separately. So get on the case, get that installed. You never know with IBM, they might make it chargeable again tomorrow. All the SQL statements we've used during this presentation and the slides can be found on our GitHub page. This can be found at FormaServe/f_learning. You'll find all the examples there. If you need any further details about open source or IBM I, check out all our videos at learning.formaserve.co.uk and the articles we have written for Powerwire.eu. I hope you find them useful and let us know if there are any other topics you want us to cover. In this video we covered some significant features and benefits of IBM i. We hope you found this video informative and helpful. Learn from our experts and boost your skills on IBM i. Visit our website today and sign up for our training courses, or buy us a coffee to show your support for our creative work. Thank you for watching, and we'll see you in the next video.